Thank you very much for the introduction. Today I will tell you about CSS and component development. You see that here it is like in 2018 because besides I'm working, I'm giving such lecture every year in Aalto University, and today Mikhail invited me here in Turku. And basically, because the industry is very much evolving, the content of this lecture also develops every year. And like this is the 2018 version, it's like the freshest one. As was already introduced, I'm from the industry. So I will be discussing with you and telling you about CSS from the industry perspective. Currently I'm working on what is called design systems, but basically as a buzzword, this appeared just recently, several years ago. But even since there was no such a trend, I'm still working on different component solutions in front-end technologies. And, nowadays it's all framed in this design systems concept. From a CSS perspective, it is developing some components in CSS which could be reusable across website or a range of websites. And before coming here to Finland, I spent some time in Amsterdam working for Telegraaf Media Group. This is like Helsingin Sanomat of the Netherlands. And before that, I spent 6 years at Yandex, developing different websites of Yandex for millions of users, and working for a component library to be used for major of Yandex websites. So wrapping it up, my expertise all those years was components on the web, no matter what are the technologies, and it might be called design systems or button libraries or style-driven development. I will show you also in historical perspectives how the concept evolved. So in today's lecture, I will show you what are the industry challenges when developing CSS and what are today the solutions, different kinds of them, to these challenges. This is a citation from specification of CSS, first published in 1996, so basically more than 20 years ago. As you might know, it stands for cascading style sheets. So anyone already used CSS here? Yeah. That's very good, so we will have maybe we might have proper conversation. And as you already used CSS, I guess it's interesting to know that you were using quite mature technology, over 20-year-old technology. But what's interesting about that? Do you like this website?
There's no blink there.
Yeah, it is. It's just a screenshot, so this is why. But why I put it on the slide it is because this is a website of about that years, 1996, when CSS as a technology was introduced. And back then, the whole web looked like that. And this is basically what CSS was made for. It was made to develop pages like that. But we cannot imagine Roper brand having website like that nowadays. So there are much bigger challenges currently, but technology is still the same. And this mismatch is very, very tricky to handle. So I will show you in details why. This person is Dan Seiberholm, and the picture is a screenshot of his book, Bulletproof Web Design. Now, he was the first person who actually said that what are the industry requirements to the website from perspective of developing CSS. This is quite mature book. I do not remember when it was published, maybe 2006, something like that. So it doesn't give you any modern suggestions how to develop CSS, but I mention in this book because Dan was the first person who actually articulated that we need to develop stable, he called it bulletproof websites. Unlike the development for desktop or other different kinds of development, in the web you cannot predict what is the browser which a user will open your website with. And a browser may appear next year after you have developed the website. So your product should be so stable that even new browsers would handle it. And another aspect is that on the web everything is changing all the time. The products are being developed again and again, and the CSS provided should handle this situation as well. So no matter the technologies, which are very different from 2000 to 2006, this concept is still valid. And this book, it had 3 editions already. And if you're interested, you can still find it and think about the requirements as a concept. And, when speaking about developing for the industry, mostly I'll be speaking about what I call big CSS. I will show you what each point means. But basically it's massive websites developed by big teams, and the UI is very heavy and the projects are long running. So big CSS means that there is a lot of code. The code base for websites is thousands of lines of code. It is not anymore possible to keep it in your head, so there should be a system how you store this code and how you operate this code. And this code is used to render many pages, sometimes thousands of them. And this is only if we are speaking about a single one website. Often happens that one brand provides several products. They might be even for different platforms. For example, several desktop products and several mobile applications or mobile websites. And they still can use the same code base, or they can share some parts of code base. And of course, business cares about providing corporate brand style across all their products. This also should be handled by CSS solutions. And these products, since they are so big, they are supported and they are being developed by large teams. Hundreds of developers is not a wow, it's like new reality. Even in Finland, we don't have really giant web companies, but hundreds of developers is reality in Finland as well. And these teams are constantly growing, and also people are leaving, people coming, and everyone has to be on the same page. with the other team members. And also business requirements sometimes say to switch people from project to project. So the developers need to be able to change the context quite fast. And this all should be kept in mind when making CSS. This is a screenshot of one of the Yandex websites. It can be whatever website I just chose. I just chosen Yandex as an example. Now, I would like you to look at this login form, which is just 2 inputs and basically 1 button. From user perspective, it's not as much. So the whole website, it contains much more other UI elements, and this is quite a simple page. So on more complex pages, there are even more. And if you looked into the code for this UI element, there is no need to read it. I just wanted to show you how many lines it is. And it is only HTML for this login form. And each HTML element has some CSS classes, which means that there is CSS to provide, I guess, at least 3 properties for each HTML element. So basically, CSS must be 4 times longer, and this is just my assumption. So in fact, I guess it might be even 10 times longer. And this is how much code a developer should produce only for just a very simple UI element. And if you imagine to scale it on the large website, how many UI elements it has, it will be enormous amount of code. So this is basically what is called heavy UI. And of course the projects are long running, so code live for years. It cannot be, it should be good enough to live several years. Also considering that new developers come and they probably need to maintain this code. So this is a reality. In many projects they do so-called continuous development. So they may release their services, the websites, sometimes even every day. So it should be good enough to live long and good enough for constant updates. And keeping these requirements in mind, so I'm wondering, and I would like you to think about what is hard about that. Why is it hard to develop CSS for these things? So this is a picture from internet. Often CSS is often illustrated like that. So yeah, you change something in one page and then in another page it is like that. So there is a lot of jokes about CSS like that. And it's the fact that people consider it hard, even though many say that it's not real development, it is not a programming language, it's just some declarative description of the styles. But still, it's a reality that people struggle when developing CSS. And so, why do you think it happens? So before we start thinking about that, let's have a look at this code. So how do you find it? Anyone? There is no trick here. So don't try to be don't try to find it. It's just normal CSS. Just your opinion about that. Would you write anything different, or is it okay? Yeah. Anyway, please.
for a small website, it should be okay for one page, something like that. For one or couple of pages.
Yeah. Yes, please?
You can resume the A to the, like you resume the code for A, but then you can just change the colors of that one, so you can reduce
Yeah.
a little bit.
Yeah.
But the rest,
Okay. Yeah, yes, please.
I don't think it would cause problems depending what is the browser set up stuff. Or the browsers have own presets, so it could be look very different in another browser and different browser.
Yeah, there is such problem, but I haven't tested that, but it's so simple, I believe it's cross-browser. But there is some problem that. Yes?
Oh, yeah, I think it's too general. It works. It
Yeah.
works everywhere.
Yeah.
It's not, they're not using IDs there.
Oops. What happened? It works here. Maybe.
It's fine.
Yeah. Okay. And actually, there is nothing wrong with it. This is CSS, like from technical perspective. But this is the exact piece of code which was published in 1996 when first specification of CSS was released. So this was an example there. And basically, the problem with this CSS nowadays is that you can see that the styles are quite simple here. So it says which color it should be, should it be bold or not, and also the possibilities in the first specification was that it could do something with text. And basically CSS was invented for that. It was made to make text bold and to make links underlined. So this was what CSS is meant for. And these capacities are so different with the requirements of industry web nowadays that it provides enormous challenges. So what I think is, when you developed CSS, what did you find the most challenging? I guess there were some things were quite obvious, yeah, how to make text, but some things are sometimes not so challenging. For example, for me it was sometimes vertical centering was quite hard, and there are some other challenges as well. So if you share with each other, or like, if you say out loud what are the challenges you faced.
working with different screen resolutions, screen sizes.
Yeah. So like basically, this is you cannot predict which size would be the which screen size your user will use, and they can change it. Yeah, this is a good point. Yeah. So then vertical centering, as we mentioned, and then what else if you could recollect? The cross browser compatibility also. Yeah, people name that. So yeah, this is not full list, just example. Like that people name that it is hard to make vertical center, equal height columns, browser inconsistencies, and this different screen sizes is very good example. It probably should be added here. And some people say that they need to memorize unobvious tricks that it's not they do not understand. They need to provide like certain amount of properties to get some results, and they always have to Google for solution because they cannot memorize it. It's not logical. Why you need this? So this is also often mentioned. Okay. But I think that today I want to show you that the previous list is not actually the CSS challenges, because as I mentioned, you can Google for the solution. There is a stackoverflow.com website where there are like answers to all the questions. And if you have some like trouble, you can like Google like how do I do this, and I guarantee they have been already people face the same challenges, and there are solutions developed. You can just copy paste, and if you are responsible enough, you can read before you copy paste. Yeah, but basically it will be fine. But what is really makes CSS hard, and there is no obvious answer to that, is that the design of CSS and how we apply it to the reality. So basically CSS was designed without any scoping. We will go through all the points, it's just like introduction, so there is no scoping. And there are specificity conflicts in CSS, non-deterministic matches. I will show you what does it mean. And there is no dependency management, and it is absolutely not clear how to remove unused code. And this is like specifically industry problem, because when developing a CAD homepage, you do not care, because it's just developed and released. But on the industry level, this removing unused code is the really big problem. So let's have a deeper closer look at everything. So the scoping means that in CSS everything is global, and writing CSS code is very much as writing some other program in maybe high-level languages, if only global variables are allowed. So there is no local variables, only global variables. And if you write CSS like that, it will affect all the links across the web page. And if you link the CSS to many pages, then all the links across the whole website. And of course, you can make it more specific. You can say that only links in lists. But this will again affect all the lists which have links. And keeping in mind that our website can be developed further, especially in future by other people, this becomes really challenging that everything is global in CSS. Then the next thing is specificity. This is the parameter by which browser decides if to apply certain rule to an HTML element or not. So basically the most specific method. And I will show you an example. So if you have some simple HTML and then some CSS code which defines different colors for these texts, sometimes people think that the latest matter, because second overrides first and third overrides second. But in CSS it doesn't work like that. So browser calculates specificity, and it calculates it based on the selector. So the most specific selector beats less specific selectors. In this example, least specific selector is this one, because it only defines the tag. Then this selector is more specific. It's not only span, but span which has some like div around it. And the third one is the most specific, because it is some span inside of div, but div should be with specific ID. And so if writing like that, no matter how much you write below, this one will override it. And on the industrial levels of CSS, it's a problem because, again, you cannot provide low specificity, because maybe there are some third-party CSS, you need to override it. But you also, at the same time, you cannot foresee the future, because new people come, and even yourself in the future, you will probably need to provide new CSS to the, keeping this one, you will need to provide new CSS for some parts of the web page. And then you bump into these specificity conflicts. So in WordCast, it looks like that. You see a code like that, and then like you have a need to do something like that. So what actually the code you write? You write something like that. So okay, it was to the left, I want it to the right. So does it work? Until you refresh your browser, you never know, because maybe it doesn't, because there are some other CSS which is more specific than yours, and then you need to provide additional additional ancestors to your selector to make it more specific and finally override the previous CSS. In Stack Overflow, there is a lot of questions when people are using Bootstrap, and Bootstrap has selectors like that, which is very, very bad, but it is still a very popular library. And people are struggling to tune something, so because they write CSS as they can with simple selectors, and it doesn't work, because Bootstrap version is more specific. And it looks like that. Not only developing with Bootstrap, but even your own CSS, if it's big enough, it will give you problems like that. Then non-deterministic matches, what it means. Let's say that we are sending an email, not email, just normal mail to our friend to Germany. And we are taking an envelope, and they are writing like some Strasse, house number 1, and to Berlin, Germany, and zip code. Then we are bringing it to Posti, and Posti knows that it is Germany. They send it to Germany. And in Germany, Deutsche Post, or how is it called? You should be a specialist. Okay. So they get this envelope, and they know it should be delivered to Berlin, to a specific street, and to a specific house, and be given to a person. So this is deterministic matches. And in CSS, it's not like that. In CSS, it is like, send this letter to a big country, to a street with green trees, and second house on this street is red, but you don't need this. You need another house, which is small, and this letter should be delivered there. So this is how these selectors in CSS work. So you just write like, it should be about like that. And then browser decides where. And again, this problem of foreseeing future, because you need to be so careful about your selectors that it doesn't break anything when the structure, the HTML structure of the document changes. Yeah, like that. There is a lot of GIFs. I had no trouble to find GIF about CSS. You just Google CSS GIF, and there's a lot of things like that. So, and another problem is that there is no dependency management. So, of course, there are these syntax for imports, but they are not developed as good as they should. So in some browsers there is limited of the amount of file to be imported. In some, and also if they are not gathered into the same file, there will be too many requests and the website will go slow. So yeah, import exists as concept, but it is not an industry level solution, so no one actually uses them. And the last one is removing unused code. This is, as I said, appears on the industry level because the project might have 100 pages, And nowadays pages are even dynamic, so there is thousands of scenarios. What are the dynamic elements to appear on the web page? And when you consider if to remove CSS or not, you never know if this removal will affect anything on the website. And it's not, it's too many pages, it's not possible to check manually. And also with some testing solutions, they help, but never 100%. So it's not, this removing unused code is really a problem. So you see sometimes it's even piles of code. You see it and you never know if it's used ever at the website or not. And so wrapping it up, this what is hard part, I would say that these things you cannot actually see here, the highlighting, can you? No.
Yes.
Yeah. Yeah? Okay, so this thing, the properties, it is not so hard. You can learn it, you can read it in the book, you can Google, you can find answers with Stack Overflow. But the writing selectors in CSS, this is like architectural problem. This is very, 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 very hard. And there is no certain answer to that. So how we make encapsulated components in CSS so that we could use them anywhere on the page. There is, this is like ongoing process to find solution for that. And I will show you like how industry, what is industry answer to these challenges. So there are 3 ways to deal with that. So first thing is what standards, like new standards in technologies, which W3C gives us. And then methodological approaches, and the last one, technological approaches. So I will show you a little bit of the standards, then we will speak a lot about methodology because it explains why. But I really suggest you to pay attention on the last one, on the technology, because this is what you could find information about after the lecture. And this is what you really can use in the project. So this standards thing, as I mentioned, there is an organization called W3C. It develops standards to be used when making web. And this organization introduced CSS, and it introduces also other technologies. And W3C, the standard answer to the challenges, is called web components. So they made this list of technologies: Shadow DOM, custom elements, HTML templates, and HTML imports. And together, using all the 4, you can develop with an approach which is called web components. Some browsers can already use it, and it somehow solves the outline problems. So I will show you examples, but this is really not the focus of the lecture, because in fact there are not so many projects using web components. Yeah, they exist. Maybe you end up in the project which is using web components, but the probability is not very high. So maybe it's better to concentrate on other technologies yet, and then if you have time to have a look at web components. Yeah, but for overall understanding, I prepared several examples, and actually after the lecture we will send a link to this presentation to all of you, and you can have a closer look on them. So I will show you quickly. So what web components mean. video, and it has some like link to video file. And if you open it in browser, it looks like that. You can watch, of course. Yeah. You can see that there is a lot of elements here, like you can make pause, you can like scroll a bit, then like a lot of elements, but you didn't try tags for these elements. Browser understood itself that if it's video, it should be transferred into. Actually, I will show you in here. You can find. I don't remember where. Okay, there is somewhere in settings there is a tick. You can say show me shadow DOM, and then you will see that this is actually div. This is some other element. So browser itself translates the simple video tag into a lot of them. And other examples, they show that you can make custom, for example, custom web component. It's just a button. Let's make it bigger. Custom button. And in here, like there is, it is like my button. And there is some JavaScript with teaches browser what are the styles to apply for just my button. And sometimes you can even add JavaScript. So you can study yourself if you want. The web components, they, since they do provide this encapsulating, they made it possible to create libraries of components to be shared. And if library, you can link, like the code I showed you, you can have many components in there, link the library, and using some custom tag, have really complex UI elements on your web page. So, but the problem with web components is that not all the browsers support them. And since there are like 4 technologies behind, it will only work if all the 4 are supported. Like on the industry level, we cannot use these native web components unless we provide some additional things. So the additional things are polyfills. So these are basically some JavaScript code which detects that the browser, this specific browser does not understand web components, and it tries to emulate this functionality to understand like the syntax of web components and behave similarly to the browsers in which this is implemented. So technically it's possible to use web components with additional polyfills. So it looks like that. You provide additional script here, and then the same code should work. And there are ready-made components, like component libraries. So, for example, Polymer or library of components by Google. So they are basically made to provide you with very basic components like maybe tab selectors and like drop downs and such. So again, if web components worked in all the browsers, it would be really nice because we could share the work of each other, and the development would be not so low. The volume would be less. So examples with let's see if it works. So examples of these components works. So you can see the map here, and if we go to code, so it's just like that. So it's just one tag. So I linked the Google library, and I linked the polyfill to make it work in all the browsers. And just like that, without any JavaScript, I have this one. So it is so because of that. Yeah. And there is no controls here, but if you provide additional controls in the tag, it will work, and you can make it bigger, smaller, and so on. So again, you can study these examples and the code when you get the link to the presentation, if you have time. But now let's go to the next point, which is methodological answers to these CSS challenges. And this is what is, I would say, much more in use than web components, even though probably not so good. And so what does it mean, these methodological challenges? So it means that not solutions. It means that, like, people, the developers, they agreed that yeah, there are some obstacles in CSS, so let's agree on limitations, on some methodology to follow, so that we never bump into these obstacles. So this is methodologies in a nutshell. The first methodology in CSS, which is quite publicly adopted, was object-oriented CSS. It was made by Nicole Sullivan. I actually will share names with you. This is on purpose. This is because the front-end development is quite evolving industry, and there is even a joke that every 2 weeks we have a new framework or new technology. And it's only possible to follow if you know the people, the trend makers. And I do recommend the people which I introduced, I do recommend to find them, and maybe to follow them on Twitter. So they already came up with the solutions to the challenges, and this means that they will provide new solutions to new challenges in the future, or they will introduce new people which you can find and follow again. So Nicole, she was working for Yahoo back then, and she was developing a library of components for the whole Yahoo, and was struggling the same challenges which I outlined already. And she tried to provide some principles when developing CSS, which are very similar to object-oriented programming, but in CSS context. I will not show you exactly like what are the ideas of that, because it is not actual anymore. I think no one uses it anymore, but still it is important because she was a pioneer. It was the first attempt to solve this problem. The next one was SMUGS. It was developed by Jonathan Snook, and he published a book about that, and it was quite popular methodology. So it was a bit more mature than object-oriented CSS, and maybe there are still some products which follow the methodology, but again it is quite old, so the new projects probably don't choose it. And what I will show you a little bit more, the methodology called BAM. This is now a highly adopted methodology all over the world. And the creator is Vitaly Harisov. He was, back then, he was a head of front-end development at Yandex. And another person, Sergey Berezhnoy, he was co-creator for BAM and also working for Yandex for search engine department. And I was very lucky to work with the guys. introduce BAM to the world. Yeah, and this is why I can tell you a little bit more about that. Basically, BAM is not only about CSS, there is associated JavaScript framework, template engine, and even building system with a lot of supplementary tools. But we will not touch the others. We will only be speaking about CSS methodology, because to be honest, the other things, they are not so popular. But CSS part of BAM was really adopted by all over the world, and now you can, no doubt you will end up in the project where people know what is BAM and probably use it. And why it happens so much is that because these guys, Harry Roberts from UK and Nicholas Gallagher from USA, they are one of the most wanted speakers at the conferences in front-end. They found out about the solution and they worked a lot for popularizing it and explaining people the ideas behind it. And these voices were heard, and the methodology was adopted very much. So I will introduce it to you quite quickly. So the BAM stands for Block Element Modifier. These are three entities, three main things of BAM. So if you look at the screenshot, let's say it's a web page, like just regular web page with some header, menu, logo, and then some footer and content in between. If we look at the page as developers, and we can outline the building part of it. So we can say that, okay, menu is one piece, logo is another piece, and search form and login form are two other pieces. And this is what BAM does. So it says that each meaningful element onto the page, a piece of interface, is block. And in CSS, in HTML, my highlighting is not visible. Okay, I will show it. So here I highlight class something. So in HTML, each block we mark with specific CSS class, and the name for CSS class is some meaningful word, which is the name of the block. So here there is a big block which is called page, and inside there is a smaller block but still big enough called header, and inside there is another block called logo. No matter what's the tag. If it has class some word, then it is block. BAM does not recommend use IDs as to address HTML and CSS selectors, because it is believed that someday you will need to have the same, a similar block at the same page, and ID, as you know, it can be only one unique. It should be unique across the page. And even if it's some piece of interface which seems to be not repeatable, I can have only one menu on the page, but still there can be situations that it repeats. Then the next entity is element, and these are small things inside the blocks, but on their own they probably do not mean anything, because for example, you cannot have menu of one element, it just doesn't make sense. But together they can form a block, and this menu tabbed pane is quite a good example. So each tab here is an element, and together they make a block. Again, in CSS it is marked with in HTML it is marked with some CSS class. So here you can see that it is tabbed pane __tab. And so, and look at the first line, it is all inside that pane block. So when writing elements, when creating names and classes for them, you need to prefix the class for an element with the name of the block and then underscore, underscore. This is made for this, like, it is an attempt to provide encapsulation for the block, which CSS doesn't have. So this is a scheme, like how to write. So this is types for block, and for element, it is under the type selection. Of course, there is technical possibility to use cascade and write something like that, like element inside some block tag. But it's not recommended because these non-deterministic matches. If you have really complex structure and there is one block with elements and inside there is another block with elements, you never know if it belongs to boots or to panels. So this is why this prefixing is recommended. For the situations when we have very similar components but a little bit different, there is the third entity which is called modifier. So modifier is something which you add to a block. So in here you can see menu block and there is some addition, menu hyphen hyphen footer, and which makes the font size for such a menu a little bit smaller. It doesn't affect original menu block. It's only like overriding for the second one. This naming scheme for modifier is block hyphen hyphen modifier name. And it is different from the element because elements are underscore underscore. And it was specifically made two symbols because it was easier to read, especially when you're looking at a lot of HTML text. So this is why not just one hyphen and not one underscore, but two. And of course, you can modify not only blocks, but also elements. The perfect example is this selected menu when there is a lot of menu items, but one of them is a little bit different because they are on focus there right now. And it is made by analogy. So you provide modifier for an element, but in here you prefix with the whole construction. So first it is block, then which element it belongs to, and then what is the name of the modifier. So this is just to repeat the naming scheme. Again, it is possible to use what is called combined selector in CSS. You can say only the menu which also has footer class. Technically it is possible, but in practice there was a lot of like it could provide some bugs in unusual places. Also because it increases specificity, and if you have selector like that, you cannot later override it. Like you cannot provide modifier for a block and override the element, because this will be more specific than this one. And you cannot say like, okay, I make exception one time, I write this because it's shorter, because exception by exception the code will turn into mess. So the methodologies, their key feature is that they only work when they are everywhere. So if the whole website is made in accordance with the methodology, then you can experience all the good things of it. But if somewhere it is not followed, then you can lose all the good points. And there is no need to write this long CSS classes, because if you are using preprocessors like SAS or LESS, they already know what is BEM because it's a very popular concept. And in SAS or LESS, you write like that. You include CSS for modifier or for element into CSS for block, and then it knows that this should be transferred into block ---- modifier, and this should be transferred into block __ modifier. So it all happens automatically. You do not write manually these classes. If you need to know more about BEM, then I recommend this website, getbem.com. It also has frequently asked questions, and this is because this methodology probably contradicts with the nature of CSS in some points, and often happens that when learning about that, people have questions like, what if, why not? And this website, in its frequently asked questions section, it tried to answer these questions. We solved such problems, so we got some scoping. But in here, you have to understand that BEM doesn't change the nature of CSS. It is not a new technology. And so this scoping is like scoping. We pretend that we have scoping, and if we follow the methodology, we hopefully don't bump into the problems of everything in CSS is global. Then specificity conflicts are solved in some way, because BEM strictly limits what kind of selector you can use. And non-deterministic matches are also limited, and there is some kind of dependency management, and removing an unused code became easier, because every piece of interface has certain name, you know what it is and where to find it. In the last years, provided the most advanced solutions to the outlined problems, and these solutions are in the technology level. So it tries to automate the things which we try to achieve with them. There are a lot of technologies trying to solve the problem, to provide different modular CSS solutions. And I will introduce you three, the most important. So these are used in real projects. So it's CSS modules, GSS, and style components. The list is by the time how they appeared. So first one was CSS modules, then GSS was introduced, and the youngest and the most advanced one is style components. But accordingly, I would say that most real projects use CSS modules nowadays. Some of them use GSS, and style components is the youngest and most advanced technology, so like some new projects may use it. The first one is CSS modules. So it was introduced by Glenn Madden. So the idea is like that. When writing CSS in traditional way, you provide some class name, here it is title, and then you provide some CSS associated with this class name. The browser understands that these properties should style the tag which marked with corresponding class attribute, and then everything works. In CSS modules, the difference is that you import the CSS into JavaScript file which outputs HTML, and in these variables, here it is called styles, but can be whatever. In this variable, you get a list of classes used in this CSS file. And then you can apply this class name to the HTML which you output. And there is some result. So let's go. And in browser, you will get something like that. So it will be generic class name, not title, but something blah 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 title, depending on the naming scheme you have outlined in the building tools. But in CSS, you will have corresponding class name, and everything would work in traditional way. And the only thing would be that because this class name is so complex and generic, it provides you this encapsulation thing. So basically, I would say that it is like BAM for free, automated BAM. Because here we were trying to provide these unique names with following some methodological approaches. And here we have the same, but in more automatic way. So we write some very simple classes, but the building tool knows that it all should belong to some block or modifier or element, and then they make like unique classes for that. So with CSS modules, we can get scoped and fast selectors, and this is kind of BAM for free. And it makes us reuse code because we can link the same CSS to different components. And CSS modules are framework agnostic, so they can be used with React or Angular or whatever. But the problems are that the syntax is not standard, and it requires building the building step, which makes development longer. And there is no dead code elimination, so you still do not know if you can remove something or not, especially if you import the same CSS to several components. Then the next solution is GSS. So it was managed by Oleg. He recently changed his surname and he asked me not to mention it. So now it's like a concept, Oleg. So this is the syntax of GSS. And what you write is kind of in between of CSS and JavaScript, because this looks like really object in JavaScript, like some hash. And nesting is possible here, and it works very similar to SAS or LESS. So basically, GSS knows how to process this button with specific property, and then hover, which belongs to button, with another property. When writing a component, you would do like that. You will have some component applying classes to itself, and then you provide with this special method inject sheet, you will provide some styles to style your button. And this also actually opens possibility to style button differently for different purposes. So there is some more flexibility here comparing to CSS modules. And when having this possibility in mind, you might architecture your application a little bit differently. So GSS provided scope in isolated components, and with GSS, actually unlike CSS modules, with GSS you can write the styles in the very file. So here I imported it, but nothing prevents you from writing CSS code right here together with JavaScript, which outputs HTML. And GSS doesn't provide the additional building step. It should make development faster. But if everything is so much automated, why do we still write class names? Why do we even care about how to name these things? Because there's another joke, which is partly not a joke, that it is one of the, like there are two complex things in programming. It's like, first one is, how is it? Cache invalidation. This is hard problem. And another one is naming things. So everything else is easy. But these two things are very complex. And if we can solve one of them and not to name anything, this will be like 50% of problems solved. Now, in CSS, styled components try to do that. So styled components, they were introduced by a group of developers. Here you have photos of 3 of them, and there were many others. So if you find how many pull requests were made in the styled components, you can see how many people contribute. The syntax looks like that. So in JavaScript, you can write styled, then .tag name, and inside as a text you can write pure CSS. So it's the same syntax. No need to learn like additional keywords. So this is exact CSS to write. And then you can say that draw me title with such text inside. And styled components as a technology will understand that these should be translated into H1, and it should have CSS properties like that. Because it is JavaScript, you can provide whatever programmatic code here. So in here I wrote that you can have access to props, which is property, but in fact it can be whatever calculation. So you do not even need any CSS preprocessors, because you can write in pure JavaScript, which is much more powerful. And this example shows you that for a button which does not have primary as a property, it makes the background white and it makes the text green. So as a result, you have this button. But for a button which has primary as a property, it makes the other way around. It makes the background green and the color white. And so you get this button. But for that, you write only this, button and button primary. In browser, it would look like that. So you will have 2 different buttons with very generic class names for the class attribute. And you will have associated CSS, which have the rules you wanted. But you do not care about the names. Everything happens automatically. You just, let's go to the previous slide. You just write that you want a button with specific CSS properties, and you want another button with a little bit different CSS properties. Yes, please.
But this style would be applied to all the buttons that you have, or can you like...
To all which you output like that.
So it doesn't have to be, so I can have like my own, like my button, and then I say style.my button.
Yeah, it will not affect these buttons. It will just like only the one which you output like that. You can have, if you manually write some normal button, it will not be affected. And so with styled components, don't know if you see or not, but I highlighted the word components there. Because to my understanding and to my perception, this is a real attempt to provide this component approach in the CSS development. Now, with style components, you don't have to think about class names, and you don't need any manual class component mapping, which makes everything really very fast and makes you focus on proper thing. And the good thing is that styles reflect the state of components. It's again some additional possibility which you keep in mind when architecturing the whole application, and it might lead you to nicer architectural solutions to the whole applications. So the authors of style components themselves outline on their website that this mapping between styles and components is a big thing. And it really is, because it changes how we see the whole process of developing CSS. So basically, that's it. This was quite a, I would say, more leading lecture, because to be able to apply it in practice, you really need to find information yourself. This only gives you like the keywords for Googling and explains like which is which. So today we spoke about what is big CSS and what are industry challenges, why it is different than developing category page. And the solutions to the problems which, in this big CSS are web components, then BEM, CSS modules, GSS, and style components. We will send a link to this presentation. Yeah. But basically, here it is on the web, so you can always have a look. And if you want, you can contact me personally for the contacts I provided. Or if you have some questions, it might be easier to ask them personally, or we can have discussion now if you want. So that's it.
Yeah, let's think. All right.